Alright, now what we'll be doing is working with solving systems of linear and quadratic equations. Okay, so you can either graph the two equations and see where they cross, not as exact, or you can solve them algebraically, very exact. Okay, so some examples of what we're talking about. So if we are actually working with a system of equations, okay, we can have the parabola or the exponential model, whichever one you want. Well, it's probably just going to be the parabola. Okay, and then if we had to graph a line with it and say, okay, this is my system of equations. Okay, all right, my answers, I could have two of them, one right here, one right there, or I can have one of them, and they will be very specific as to which one it will be, which would be right down here. More than likely it's probably going to be a straight across line. I'm just doing that just for the fun of it. Okay, or you could have no answers. Okay, so you could have 0, 1, or 2 answers when you're solving a system of linear equations. Okay, now when you do solve it, just remember the first coordinate is your x, the second coordinate is your y. Graphing shouldn't be too hard. You can actually use it to check your answers when you're solving algebraically, just to make sure you're on the right track. The main thing that I want to have you guys do is to be able to sit here and look at a set of equations and to be able to solve them algebraically really easily. So that's what we're going to be practicing, okay? Alright, now this one, some people would like to use like elimination right here. I don't recommend it because that's a 2x squared and that's a negative 2x. The 5s, yeah, they kind of get there. You could go ahead and do elimination if you wanted to get rid of the y's, or you could do substitution. It's totally up to you how you want to do it. I'm going to go ahead and do substitution, and I'm just going to say, okay, all of this y right here is equal to this, so I'm going to replace it. So what I get is negative 2x plus 5 equals 2x squared plus 1. Okay, now if you notice, I have an x squared, an x, and a constant, so that means solving by the quadratic. So I'm going to move everything over here. So I'm going to minus the 5 here, and then I'm going to add the 2x over here. Okay, if you remember, you have to do it to the same side, so plus 2x minus 5. Okay, and so what we get is 0, and the reason why we want the 0 is because of the 0 product property. So this becomes plus 2x minus 4. Okay, now if you notice, I can factor out a 2 out of everything, so I'm going to divide everything by 2. Okay, so if I divide everything by 2, and this is a totally legal move as long as you do it to both sides, I'm going to be dealing with 0 equals x squared plus x minus 2. Okay? Now, just factoring that alone, okay, let me see. What two numbers multiply to negative 2 but add up to 1? I would say positive 2 and negative 1. Okay, and I just flip the 0 over to the other side. Okay, and now what I can do is I can actually plug in my answers. So x plus 2 equals 0, or x minus 1 equals 0. Okay, and then we just solve that. So we minus 2 from this side, we minus 2 from this side, and we get x equals negative 2. Okay, and on this one we go ahead and we add 1, okay, and x equals 1. Okay, so now I get 2 x's, so that means I need to find 2 y's. So first one, and this is the cool part about this, the first one is I'm going to plug it into here, and I'm going to use the bottom one just because it's easier. So y equals negative 2 times negative 2 plus 5, which is actually going to be, I believe that turns into 4 plus 5, which is just 9. So my first point of crossing, or my first coordinate set that I'm going to use as my answer is negative 2 comma 9. Okay, so that's my first one. And then I'm going to take this x equals 1, and I'm going to plug it into the same problem, except I'm going to do a different answer. So y equals negative 2 times 1 plus 5 is negative 2 plus 5, which is just 3. All right, and the other answer is going to be 1 comma 3. Okay, now how do I check my answer, you say? Good question. I'm going to show you by graphing it in Desmos. All right, here's lovely Desmos. I typed in everything correctly. Here's my parabola, and voila, here's my actual line. Okay, and as you can see, that matches the second answer I got, and this matches the first answer, so I did it correctly. Now, if you'd like to graph this first and just see what the answers is and get it real fast, that's totally fine. But if you do not get exact answers, you do need to go back and do the algebraic method. Okay, but that is it for working with solving a system of quadratic and linear equations. I will talk to you later.